Hello and welcome to our lesson on radicals, simplest form. First of all, let's talk some definitions. A radical is an expression, so that means no equal sign, that includes a number, could also be a variable, a radical sign, it's called a square root sign if it's squared, and that teeny tiny number called an index. So look, here's your radicand, it includes the x squared. The index is that teeny tiny number, and then you have that funky check mark looking thing, and that's your radical sign or your root sign. Okay, a radical that's put into simplest form happens when the radicand can't be reduced any longer. So 54, can we reduce it down to groups of 2? Yes, 54 is not down all the way, the smallest it can be. So we would say that we need to find the simplest form of the second root, or we commonly call it the square root, of the number 54, and that x squared as well. Since the index is 2, it means that we're looking for sets of 2's, or pairs, that we can pull out of the radical sign. So let's start with the radicand and create a factor tree until we found all the prime numbers of the radicand of 54 and the x squared as well. So let's take 54 first. Let's break it down into prime numbers. 54 you can break 9 times 6. And you could have done it with 2's or however you wanted to, but whatever you do it, as long as you get down to the actual prime numbers at the end, it's going to be correct. So 9's not prime, so we can break it down again to 3 and 3. And I like to put a little dot underneath the prime numbers so I can keep track of them. 6 not's prime, so we can break it down into 2, which is prime, and 3, which is prime. So we're done. And if you have x squared, that really means it's just x times x. Because if you remember, when they say to multiply exponents, they're lying. You really add them. So if you have one of them and another one, it's going to get you back up to that squared one. So we found all our prime numbers of 54, and x squared broken down is really x times x. Now, pairs go out and singles stay in because we were looking for the square root or the second root. So we broke down 54 into the prime factorization of 2 times 3 times 3 times 3. And we also broke down x squared into x times x. So those are all our prime factors. Now there are a pair of 3's, and because we're looking for the square root, they're asking for pairs. If there's a pair of 3's, they can come out. So let's see, this pair right here, they can come out because it's a grouping of 2. And look, you've got a grouping of 2 x's, so those can come out of the radicand, or they can come out of the radical sign. And then we have a single 3, which is this poor guy right here, and a single 2, which is this guy right here. And they have to stay underneath the radical sign. So this is what it would look like. There was a pair of 3's, so we just write 3 one time, telling us there's a pair, because that's what the index says. There were a pair of x's, so we just write them one time. And that lonely 2 and the 3 are left behind because they didn't have a pair. They were single. So they have to stay in. Underneath this radical sign, you have to make sure that you have simplified completely everything here, and 2 times 3 is not simplified. You actually have to do the multiplication. 6 is the simplified answer. So here, right here, is your actual final answer. That came from the square root of 54 x squared. And that wasn't simplified, but right there, that's your simplified answer. Okay, now, when we're dealing with algebra and we've got those lovely exponents attached to variables, let's do some practice. First thing you do is create a factor tree for your coefficient and for your variable. So breaking down 108, we can break it down into 2 times 54. 2 is a prime number, so we can just stop there. 54 is not prime. We have to break it down. And we can do 9 times 6. 9's not prime. Let's break them down. Now we have 2 prime numbers, 3 and 3. 6 is not prime, so let's break them down again. And we have 2 and 3. And those are both prime. And x cubed actually means you have 3 x's in a row. So anytime you see this exponent and you have to break it down, that exponent tells you how many times you're writing your variable. It says write them 3 times in a row. And that gives you cubed. Now, this index right here is 2, so we're looking for pairs or groups of 2. There's a group of 2 right here. There's a group of 2 3's. And right here is a 2 and here is a 2. So that means we have a group of 2's also. And here we've got a group of x's, 2 of them. So what happens? We're going to take out the group of 3. They come out. We're going to take out the group of 2. It comes out. And we're going to take the group of x's. It comes out. And look, we have a lonely 3 and the lonely little x. That means they have to stay back underneath the radical sign. So you're going to have a 3 and an x. And right here is your index of 2, because that's where it was originally. Now, this is not simplified yet, so we have to go ahead and simplify it. So 3 times 2 is 6, times x is 6x. And then 3 times x is just 3x. And your index is 2. So right here, that's your simplified answer for this guy right here. Can't break down 3 any further and can't break down x any further into pairs, so you're done. All right, let's look at the next one. Now we're going to take 54 and y to the 9th. So let's break 54 down, and let's also break y to the 9th down. So 54 would be 9 times 6. 9's not prime yet, break them more. 3 are prime. Both of these 3's are primes. And then 6 is not prime, so we need prime numbers, and there they are. Now this guy right here tells me how many y's I need. I need 9 of them. So I can have, let's do rows of 3. So I have 3, 4, 5, 6 9's, 7, 8, 9 y's. All right. Our index now is telling us we need to circle groups of 3. I have a group of 3 3's and a lonely little 2 left over. He's right there by himself. I have groups of 3's also. I have 1 group, 2 group, 3 groups of the y's. So anybody that's grouped together goes outside the radical sign. I have a group of 3's, and I have 1, 2, 3 groups of y's. When I counted these up, the number of groups that I have of variables becomes your brand new exponent. That tells me that I have 3 groups of these y's. Now, who's left over? That lonely little 2, and he stays under there. And if you remember, when we did double checks, and this is to the 3rd power, when we did double checks, we had to take this number that many times in a row, so 3 times 3 times 3, which is 27, and 27 times underneath is going to give you 54, so that's correct. When you double check this guy, though, you only multiply the 3 exponent and the 3 index. So 3 times 3 is 9, and that gets us back up to the original 9 that we were looking for. So hang on, let's try it again. So we have a 24 and a z to the 16th, but we don't have an index. If you don't have an index, it immediately defaults to 2, which means we're looking for the square root. So let's take 24 and factor tree it, and let's take z to the 16th and factor tree that as well. So 24, you could do 2 times 12, you could do 8 times 3, 6 times 4, it doesn't matter, you're going to get the same exact answer in the end no matter how you do it. 2 is prime, so we're good. 12 is not. Let's go ahead and break them down into 2 and 6. You could have done 3 and 4. It'll still work. 2 is prime again. Now let's break down 6 one more time, and you're going to get 2 times 3, and those are all primes. So we broke them down into primes. Now, if it says z to the 16th, that means we get to write 16. That means we get to write the variable z 16 times. Won't that be fun? That's what that's telling us right there. So any time that you see the actual exponent, it just means to write that variable that many times. So we have 8 of them, and then we have to do 8 more. And even though it seems tedious, like, do I really have to do this? Yes. If you don't write them all out, you're going to end up dropping a pair, or you're going to miss a single guy left over, and it'll just throw you off on your final answer. So be sure to write them all out. Now again, the index wasn't written, so it's assumed to be 2. So we're circling pairs, groups of 2. So there's a group of 2's, and then the 2 and the 3 are lonely little leftover guys, so they just hang out for a little bit. So we take out the group of 2's. Now we're looking for a group of 2's with the variable z. So I have 1 group, 2 groups, 3 groups, 4 groups, 5, 6, 7, and 8 groups of 2. So that means however many groups I have becomes my new exponent. Now, we did have some leftovers, so we have to have our radical sign with the leftovers of 2 and 3. But that's not fully simplified yet. You actually have to multiply them out. So your final answer is going to be 2z to the 8th radical 6. Right there. That's your fully simplified answer. Now let's take a look at the next one. We're going to look at 64 and m to the 10th. We do have an index this time, so we're looking for groups of 4. So let's break down 64, and let's also break down m to the 10th. So for 64, let's do it by 2. 2's prime and 32. Okay, now I have to break down 32 also, so let's do 4 times 8. 4 is still not prime yet, so we still have to keep going. Now I've got primes. 8's definitely not prime yet, so I have to keep going. 2 is a prime, 4 is not prime, keep going. Now we have all our prime numbers. Now for m, remember, that exponent right there tells you how many times you're going to write m. And yes, you need to write it out 10 times. If you don't do it, you're going to end up dropping one, you're going to forget it, he's not going to get on the list, and then it's going to throw your entire answer out. So we have 4, 8, 9, and 10 m's. Now, that index back here again is 4, which means we're looking for groups of 4. Okay, I have 1, 2, 3, 4 right there. I have a whole group, just one group of 4 2's, and then I got some lonely guys left over here. So we're going to take out a group of 2's, and we're still going to have some guys left underneath. Now, over here with the m to the 10th, we're looking for groups of 4. So I have one group of 4, another group of 4, and then 2 lonely little m's left over. I have one group of 4 and 2 groups of 4. Because I have 2 groups of 4, that 2 becomes my new exponent. Now I do have some leftovers, so I need to have my radical. My index is 4. I have my 2, my 2, my m, and my m. So these guys are singles. They don't have a group of 4 to come out with, so they stay underneath the radical. But they're not fully simplified. So 2 times 2 is 4, and m times m, you don't actually multiply them, you just add exponents, remember? That's a 1, so we have m squared. So your final answer for all this work is going to be 2m squared with the 4th index, 4th root, 4m squared. This right here is your final answer. If you're still not sure and it's a little iffy for you, go back and redo these without my help and then double check and see if we did it correctly together. Now, notice the pattern with the exponents. Remember, exponents always do different things than what they're actually being told to do. If we're looking for a root, the square of the cube to the 4th root like we just did, it does not mean that you need to do the factor tree. I didn't break them down, I just listed them. For an exponent, you divide the exponent by the index. You find out how many groups there are. Groups of 2, there are 5 groups of 2. Groups of 6, there are 2 groups of 2. You're always dividing them out. So, in order to simplify a radical expression, create a factor tree of the radicand. Do that for the actual coefficient, the number. All the prime numbers that can be paired up, tripled up, whatever they're telling you according to the index, need to be taken out of the radical sign. Any remaining singles, those people or those groups that can't be put into whatever the index group says, they go back under the radical sign and they're multiplied together to create a new radicand. This works for your exponents as well. So when you're talking your variables and your exponents, if I'm trying to find this, I don't need to make the radical tree. I just need to list them all out and circle them in groups of 2, and they come out, and the poor lonely one goes back under the radical sign. Remember, the exponents always live by the different rules. And that's it for our lesson on radicals, simplest form.